This one, I think. All right, so your next lab has been pushed. The assignment doc is out. We'll talk about it at the very end. If you want to turn it on, kind of follow along with a very, very brief kind of show and tell at the end, you're certainly welcome to. There's probably going to be some time to work on it at the end too if you want to. Why is that not working? Okay, whatever. All right, so we're going to do some NAT stuff today and introduce your next assignment, which will have you working in a couple different firewalls. We talked about both of those last time we met, which would have been last Tuesday, I believe, because of snow. So look back at that video if you have questions on that too, or ask me questions on that. That will be useful for your next assignment this week. This assignment that you'll be getting today is one of the longer, more challenging assignments for students. It took me a little bit under an hour to do it yesterday after I ran into an issue or two. I guarantee it will take you a heck of a lot longer. Because of that, and because this assignment does generate a ton of questions, typically, not tomorrow, let's fix that. Thursday is going to be a work day. So next time we meet, Thursday will be a work day. I know a lot of you like to do your assignments at home and not here. We have multiple monitors and all that great stuff. I do too. If you are not done with the assignment, though, you should come to class. If you don't come to class, I will assume you're done with it, and you may not hear responses from me on emails if you ask questions and didn't take advantage of the workday. So come to class. We'll see you Thursday. This is kind of the end of firewalls. For this class, we're going to talk a little bit, or use a transition kind of day to go from firewalls through layer 7 firewalls and filtering packets a lot deeper, and then into IDSs. So I'll have a little bit of firewalls left there, but for the most part, this is it for firewalls, the traditional firewall rules and all of that. I do want to end this segment with a small quiz exam thing, because there's not going to be like a full big midterm, just because things don't fall very nicely that way. The midterm would be like a bunch of firewalls and a week of IDS or something, which is weird. So next week, as early as Tuesday, I haven't exactly figured out the schedule yet, but as early as Tuesday next week, there'll be a little exam thing in D2L over firewalls. So feel free to study out for that. Building firewall rules will be a big portion of it. Probably the most significant portion of it. Still working on building it. Questions on that stuff? Yes, multiple choice. As of now, it's 100% multiple choice, but I kind of have like 2 questions built, so we're not done yet. It'll be multiple choice, maybe short answer, but multiple choice for the most part. Ooh, good question. I'd consider it. Yep. I like doing the open note exams and things like that. There are some things that happened on the last assignment very consistently that I've been hammering everyone about, that you would have gotten hammered with in the comments as well, that I will come up on this exam. Last assignment, grades have been pushed out. Any questions on that before we move forward, or anything else? Okay, all right. So we're going to move on into NAT. I talked very, very briefly about NAT at the beginning of the semester. I think we did some intro stuff, but we're going to get a lot deeper into it. And you'll actually be configuring NAT in one of the firewalls as a part of your homework this week. NAT, or network address translation, is largely used to remap one IP address space into another. And a large portion of what it does, or primarily what it does, is modifies the IPv4 headers, specifically the IP address and port, for a number of different use cases, and we'll talk about those as we go through. The routers that are doing the NAT, when they modify those packets, they of course need to keep track of the translation and the modifications that they actually employ, so they can change things back as they pass through the router again. NAT used to be used in kind of a lazy capacity. We just used it to change IP. So if all of DSU right now, we're on a 138.247. If for some reason we got a new IP block and wanted to change everything on campus, one, that sucks to go around to every single device on campus and change it, especially the statically assigned ones. We could just throw a NAT firewall or something that does NAT in between and use that to convert all of the 138.247s to some other IP address space. It's a totally legit use case, something that's not, it's not used as much for that anymore, and there's a lot, or one much larger use case for NAT, and it has a lot to do with IP masquerading. So the idea with IP masquerading is we're going to hide an entire IP address space, typically a private IP address space, behind a single IP in another address space, typically a single public IP at your ISP gives you at home. This is largely what this is going to be used for, and really we need to use NAT for this with IPv4 to conserve addresses, right? All of you have probably 5 to 45 devices at home, you and your family, and that may require 5 to 45 or more IP addresses, and your ISP gives you one, right? That's a big mismatch. We've got a bunch here on campus, but at home that's not the case, right? And across the world, we're running out of IPv4, enter IPv6. I'm sure you all know about that whole discussion, right? NAT's probably not going to be as big of a thing with IPv6, but IPv4 it certainly is. So how does this actually happen? State is a big deal with it, and that's why we talk about stateful firewalls before we talk about NAT, right? Stateful firewalls remember sessions as they go through the firewall, so we can keep those ports open on the way back. The stateful firewall and using state for NAT is very similar, but just for a different purpose. We're going to remember the connections that are going through that firewall, but we're going to modify them a little bit. NAT will do that translation to the IP and or the port. Remember that and watch that connection, watch the state of that connection as it goes through, right? So example here, you negotiate a 3-way handshake with some destination, Google's internet or Google's website. That traffic will go through your router. The router sees your source information, some ephemeral port, right? So down here, here's your source information, 192.168.1.105 and some ephemeral port. And then it's going to throw that in some table so it remembers it. It's going to map that to your external IP in this one instance or this one use case of using NAT, this common use case of using NAT. It's going to use some ephemeral port, might change it to a different ephemeral port, might be the same ephemeral port, but then it's going to map that to whatever your public IP is. It's going to remember that combination of port and public IP. So when it sends it out onto the internet, this goes to Google. Whenever Google replies, Google's going to reply to this public IP and ephemeral port. NAT on your router will remember that public IP and ephemeral port combination and say, hey, that goes to 192.168.1.105 on this ephemeral port. It's kind of that whole round trip that happens there. So a couple different types of NAT. One-to-one NAT, also known as basic NAT. It's probably the most simple way of using NAT and isn't the use case that I've been talking about. One-to-one NAT maps a single IP to another single IP. This is used here on campus in a number of locations. The IA lab uses it quite a bit, where we map a public space or one address space like 138.247.115 to maybe a 172 something, right? Some other address space. One-to-one, very specific. Anything we see coming from this IP on the inside will always get translated to this IP for the outside, everything going out, and so on. Doesn't really need to do anything with ports, since for this private IP in this case, we have 65,000 ports. Over here, we have 65,000 ports to choose from, exactly the same. That can always stay exactly the same, right? Doesn't need to change that at all. With this other use case of one-to-many, we're probably changing ports as well. So one-to-many NAT is, again, the common kind of use case for NAT, and the technical term here of one-to-many, where we're taking one public IP address, translating that to several private and vice versa. This does require a lot of ports. So if we have this one public IP here and a bunch of different private IPs on the inside of your network, you've got 65,000 times the number of IPs on the inside of your network, ports, and 65,000 ports here. That's going to be a big mismatch. So you are going to see some ports change quite possibly during that translation, and we have to care about those ports, right? Different names for essentially the same thing kind of listed there. port address translation, network address, and port translation, because that's really what's happening when we do one-to-many NAT, taking that one public IP and a port and mapping it to some other public IP or private IP and port rather on the inside. All right. So how do we do NAT? There's really 3 different ways of applying NAT, and you're going to see source and destination NAT within your lab this week. Static NAT is there as well. So let's talk about each of those, and just do keep in mind that these can vary a bit between vendors and their terminology and how they implement things, but for the most part this will be pretty consistent. So source NAT. Source NAT deals with kind of if the packet is from somewhere and you're going to specify where that somewhere is, then we're going to translate it like this. So example being, if this packet is from the internal subnet, so if this packet is from inside your router, then we're going to take it and change that IP to a public IP, maybe to a different port so it can go out to the world. Source NAT. If it's coming from some location, do a translation to some other thing. That's kind of the source NAT. This is typically what you're going to see on the one-to-many situation when it's coming from the many going to the one, coming from the inside going out to the internet. Does that make sense? Source NAT. Some other names for source NAT there, but typically source NAT's what you'll see. This diagram has source and destination, but we'll look at source right now. So we have all of these different hosts inside of our network. Anything that's going from all of these hosts outbound is going to be source NAT. Now destination NAT is kind of the opposite and makes sense with the name. If the packet is going to a specific destination IP, then what do we want to do with it? Or maybe if the packet is going to a specific destination IP and port combination, then what do we want to do with it? What do we want to translate it to? Often, you guys have probably used destination NAT or may have used destination NAT before, but just never heard it called that. This might look more familiar. Port forwarding is essentially what destination NAT is. So if your router receives any traffic destined for it on a specific port, then I want to translate it to some internal IP on maybe the same port, maybe a different port, and send that inside, right? You might have had to set up port forwarding or destination NAT for Xbox or hosting a server at your house or anything like that, right? And a different destination NAT. Destination NAT makes sense. Questions on those two? So those are important. Okay. That's the same kind of diagram. So with this destination NAT here, where I'm translating an IP to a specific machine on the inside, would that type of destination NAT be considered maybe a one-to-one NAT or a one-to-many NAT? Where I have this destination NAT here. It's definitely going to be a one-to-one, right? So I have, in this diagram anyway, one public IP always going to one private IP, right? You see the one public IP over here on the outside going through destination NAT to one specific internal IP. On the other side, this diagram would look like the source NAT would be more of a one-to-many. If we're using a different public IP, translating that, or putting all of these hosts behind that, so all of those many private IPs behind one public IP, that's what you're going to see in this diagram anyway.
Is your traffic's going on one IP, but expecting it back?
You can, because when the traffic is coming back, it's not going to come back on these IPs necessarily. So what this diagram is kind of showing is this is more of a service that you're hosting on the outside, and that is more for any communication that starts from inside. So when you go out to Google's internet or Google's web server through whatever IP is up there, it's still going to come back through that IP in a one-to-many and travel through that same path. I've never really seen it set up exactly this way, where you would have a source NAT doing one-to-many and a destination being a one-to-one, because then you wouldn't need, wouldn't really need two hosts. Yeah. Does that make sense though? Ish. Not something you're going to see too often, but with that diagram, that's what that would be. Static NAT is essentially the one-to-one mapping. It's going to be pretty similar to a source NAT, but this is where we're going to use one-to-one to map a single IP, single private IP to a single public IP. Often on your home routers, this is really what they're going to call the DMZ area of your home router. That's static NAT. All right, so question here, and I'll start the polling. Okay, so we'll do the discussion after you answer first on your own. So imagine you have a small home network that's like this diagram. You have some web server you're hosting inside and a couple hosts, a couple of computers. There's no firewall in this network, none at all. And there are no destination NAT rules configured. We just talked about what those are. Suppose the traffic comes from the internet, some traffic comes from the internet, to your external IP, so that's 24.220.185.15 for port 80. What will happen to that traffic at that router based off of those things? Sent back, some sort of reply. Rejected is fine. Well, sent back I'll reword as like forwarded to the original source. Let me modify that for you. How's that? All right, give you like 10 seconds or so, then I'm going to stop the poll. Okay, go ahead and discuss with your group. What? Oh, and yes. New connection. It would be.
It's a new connection from the outside.
Okay.
So what exactly?
Drop.
Specifies it.
Okay. Oops.
Well, if you establish a new inside,
Then it would have that already.
so then it'll get
There you go. Yep.
Cutting a little close with these pictures.
Yeah, a little bit. I just don't like that. It's like a wall of text with that. But this one's not intended to be easy, nor is it something that we've talked about yet. What, fire alarms?
it was -4 too. And then you had console on top of it, and I didn't think it had sensitive hard first. So
So we were standing outside for like 5 minutes, waiting for somebody to come up.
Yeah, and then Deanna was just like, oh crap.
Yeah, so she's running with flip flops in the snow.
Fun. So, okay, I'm going to put a good spin on this for you. Just imagine, instead of that being a dorm, which there may be opportunities for something like that to happen, it was your home that you own in the future, where you can't just like sit there, wait for someone else to deal with it and go to bed. You got to like put some pants on and actually deal with it in the middle of the night.
Yeah, but that's what you've done to actually tighten down bolts.
Hey, it worked for quite a while. Worked through the last cold snap.
Yeah, I was kind of surprised. Like, I didn't do it while it was even colder. But,
Right.
yeah, last night. But like, when it's really heat, that probably put a stress to it.
I mean, it
You
was.
only have one quick setting basically in that floor.
Right.
You have your heat in, like they heat on and off. They don't really heat at levels. So
You can turn the fan off. You can turn the fan off, it's still better.
Mm-hmm. What did we get to last week? Like 30? Did we make it to 30 last week here? Negative?
Oh, wind chill?
And no wind chill.
we got a negative 33 of them.
Okay. Because wind chill doesn't really matter for inanimate objects. Us, it certainly does. But that's not going to make water freeze any faster. I might take that back.
Yeah.
Well, maybe I don't. I don't think it's no, because why the wind makes a difference for us is because of the evaporation that makes us colder.
So
Wind would
probably
wind also
water.
carries away energy. So if you have a building, you take it at negative 35.
Right.
Negative 35 with a 20-degree wind. This building will lose a lot more energy than this building.
Sure.
And the act of getting cool is the loss of energy.
All right, go ahead and put in your response to this one after discussing.
Beep.
Why are we beeping? Beeping's not allowed.
Beep.
Yeah, so it'll just be like, I don't know what to do on this. Available because people are so spam. Someone from many different No, this was
All right.
source. It might not be very
So this was the first time. Second time it changed a bit. I just love that. Because it actually went in the right direction. Yeah, don't do that. If you listen, I like tell you to do it too. So quite a bit of you switched over to E being none of these. If you chose none of these, what would the correct answer be? It just drops the traffic. So if there is no destination net rule, if there's nothing to say, hey, if you get something from the outside on this port, send it to this place inside, your router doesn't really know what to do with it. And it will drop it, right? So NAT might act like a firewall in this case. So I said there was no firewall here, but there's no DNAT rules, but there's NAT in place. It's blocking traffic or dropping traffic, so it feels like a firewall, but it's not actually a firewall, right? NAT does have that side effect of dropping traffic that it doesn't know about, that it doesn't expect, that you don't have DNAT rules for, or other sorts of NAT rules for. Most cases where you have the one-to-many, you're going to have source NAT set up where it's allowing all the traffic from the mini side of the network, everything that's internal essentially, and allow that to go outbound, translate that through NAT to go to behind that public IP. But in this example here where we had a packet coming into our public IP, if we don't have one-to-one set up, we have a one-to-many NAT. So if your router gets something from the outside and you haven't told it exactly where to send it, because with one-to-many NAT, if you don't tell it where to send it, you don't have port forwarding set up, it doesn't really know where to send it. So it's just going to drop it, right? Kind of feels like a firewall. It's not actually a firewall, but it is a side effect. So it would drop that traffic. E is the correct answer here. If you don't have DNAT, it's not going to send it to any of these specific servers in there. It might make sense that eventually you would set up a destination NAT rule or port forwarding to send anything that your router receives on port 80 onto that web server that you have inside, depending on what you're doing with it. But with no DNAT rules, E is the correct answer because it will drop it. Does that make sense? So it's not a firewall, but it kind of acts like a firewall in some cases. And shouldn't use it as a firewall. Have a real firewall there for it. Okay, another scenario here. So this is not extremely related to that firewall concept here. So we're going to say you are on the LAN with that internal IP 10.1. You have a server on your DMZ on a different pub or private internal IP at 10.2. So those are two different subnets, right? You can't communicate directly with that server. Does that make sense? Subnetting early on. All of that is natted behind a public IP. You can have two separate like internal addresses or internal subnets behind one NAT public IP. You can do a one-to-many there. Now, we're going to say that you, at the 10.1, you want to talk to that website. So you have a destination NAT rule set up so that this public IP, anything that comes to this IP on port 80, I think, yep, port 80, will get sent along to your server at 10.2. Okay? Anyone on the outside can get there, and that works. So now, if you, from the inside, you try to do that, you say, I want to go here. Your router says, yep, I am that. I know where to send it because there's a destination NAT rule set up from my public IP on port 80 to that server on port 80. Okay, so it's going to send that traffic along. That's how NAT works. Everything's fine and dandy here. Now that server receives that and it's going to reply with that response, throw that website back, set up that handshake, whatever it may be, to the router, and it wants to go back to 10.1.1.10, which is you. The router says, hey, I know where that is. That's on the internal network. I don't need to do any NAT to get it to that directly connected internal network, so I'll just send it over there, right? And the traffic gets back to you. Seem fine so far? The problem is it's kind of sketchy because when you ask for a server on 138.247 and get a response from 10.2, that doesn't make a whole lot of sense, right? When you're getting a response from somewhere different, someone else that you did not expect a response from. This is kind of a problem with NAT in some situations like this. If you want to use NAT, your public NATed IP from inside to get to something else that's inside, and sometimes if you have things that are hosted on the IA lab and you want to get to it from within the IA lab, we've had issues with that. And this has a lot to do with this thing called NAT loopback, or NAT reflection is probably another common term that you've heard this referred to as. This idea of NAT reflection or NAT loopback allows you to access a service that's on the inside via the public IP on the outside. So use that public IP to access something that's on the inside. It allows NAT to skip like basic routing, so your router's not going to send it back via that local IP. It'll actually do the NAT. So the you in that example would actually get a response from 138.247 and not directly from the server. That's another consideration with NAT that you'll need to kind of think about. So yeah, it has a lot to do again with that internal IP reflecting to another internal IP. We won't get this or into this too much in your next lab, but something you should be aware of. So NAT isn't all great all the time, depending on what type of services you're hosting. Some services kind of need to have their own public IP in some cases. So some examples up here. FTP, as it is doing its thing, it sends explicit network addresses along with the application data that the FTP site is actually sending. If that's behind NAT, when you're translating that IP, but then a different IP is inside of the packet itself, things don't match, kind of some issues there. Very, very similar thing here with SIP, or Session Initiation Protocol, that controls voice over IP phone stuff. Very similar situation there, right? Often that is going to encode an IP address on the inside of that packet and the application data of that packet. And if the header does not match that, because NAT has changed the header, things don't look right? It's kind of a sense of tampering, or we can detect tampering that way, but that could be issues there. So that's all I have on NAT right now. Does anyone have any questions on NAT stuff? Source destination are the biggest concepts you absolutely need to know, should know. One-to-many, one-to-one, kind of the big use cases there. All right, so I'm gonna briefly take a look at some of the areas that you would configure NAT on a Juniper firewall, since that is where you will be doing this in your lab this week. You're welcome to open up the GOAT side and follow along. And then I'll go over your homework after that, and you're welcome to get started. Restore sounds fun. Yeah, that kind of worked. So in this environment, the Juniper firewall will be at 192.168.2.1, which is in the dock as well. We're going to go over that in a moment. All right, so you've seen this homepage before. We've gone through the interfaces and the security policy. You'll be working with that again as a part of your homework. But now we have this NAT stuff. We talked about source, destination, and static. You're going to have to use source and destination here for this homework. So actually, before I do that, I'm going to show you a bit of the assignment, I guess, to kind of understand what's going on here. So now, assignments, there we go. This one. Whoops. Whatever. Please hold. Alright, this is enough. Hey, they're loaded. Okay, so this is kind of the network diagram that we have going on here. Your network, or this environment, has two separate networks, one called GOAT, one called DOG. The DOG side on the left does not use NAT. No NAT in play, all public IPs, just like we've been working with throughout the semester. So each of these networks has two web servers on the DMZ interface, one client machine, one admin machine essentially on the LAN interface. That's what you'll use to configure this. On the GOAT side, so on the right side here, we are using private IPs, therefore we have to use NAT. So on the GOAT side, you have one public IP on the internet. This link here simulates the internet. This machine here simulates some machine on the internet. Keep in mind, when you're working with internet rules on firewalls, WAN, subnet, WAN, internet, subnet is not the internet. Anything is the internet. Okay, just keep that in mind. So on this side, you're going to have to deal with NAT because we have 192.168.2 subnet down here, 192.168.253 subnet up here. Everything over here should never, ever, ever see a 192.168 because that's not a thing on the internet, right? So we have to use NAT to hide all of these, kind of a one-to-many NAT behind this IP. So you're going to do that through two different things, source NAT and destination NAT. Source NAT, again, will translate a rule if it comes, or translate a packet if it comes from somewhere, and it will translate it to something. So the idea is, if a packet comes from one of these subnets that wants to go out, then throw this public IP on it instead. right? So then when everyone responds from the other side, it comes to this public IP. It remembers, hey, I did a translation from 192.168.2.10 to 24.220.181.101 with these specific ports. It'll change that back and send it along on the inside again. That's source NAT. So under source NAT here, you're going to have a rule set and a pool as well. Adding as you would expect. You're going to have to give all of these names. When I'm dealing with kind of where this is coming from, where the traffic is coming from, I like to do it in zones. So if I have my trusted zone, for example, if any of the traffic is coming from the inside, or you can put multiple zones here if you do configure multiple zones, and it's going to the internet, that's where you want to do the source NAT. So if it's coming from inside and going out, then I want to do the source NAT. But how do you do the source NAT? First you need to give it some name before you can click add here. And this is going to be what you're actually doing. So more specifically than from this zone to this zone, you're also going to specify what IP range is it coming from. You might put your 192.168, I think it's 2.1/24, for example. Another valid option to put here that looks weird is this. What does that mean? Everything. So we already specified on the previous screen only things from trust zone, for example, to the WAN zone, for example, and the source here of anything that would possibly be within that trust zone. So you could do that. That is a valid option. That will match anything. So if you wanted to lock it down to only do the NAT if it's going to specific IPs on the outside, if you're doing a one-to-many NAT like you will be doing here, where you have a bunch of private IPs putting it behind one public IP, you're going to always want to do NAT for all of the destinations. Anytime it's going outside of your network, you're going to want to do NAT. So kind of your destination of any is going to be a good option here. What do you want to actually do? I do want to do source NAT. Make sure you change that. And it says I do want to do source NAT with egress interface address or with pool. So if you had a bunch of different IPs that were your public IPs in this router, you could set that up as a pool. It would choose some random IP for you to be behind at that time. In this case, we only have one interface or one address on that interface. So you can just select like with egress interface address. Does that make sense? For the most part, that's source NAT, right? I'd love to scroll up. Reset. There we go. Zoom out. Cancel, cancel. Okay, so on the destination side, this is the opposite way. So one of the things that you'll be doing in your homework here, can I like find this one? There we go. You have two web servers here. You're going to need to set up rules, firewall rules, NAT rules, to allow machines over there on the internet and everywhere else to access those two servers. Now you're going to access those two servers. When I want to get to Goat Server 1, I'll say, from the internet or from Dog Admin, I cannot go to 192.168.253.222, right? That's a private IP. Can't go to that over the internet. This is where NAT comes into play. So you're going to end up going to 24.220.181.101. We'll say port 80, for example. You're going to create a destination NAT rule, that's port forwarding, to forward anything that comes on this interface over port 80 to this server over port 80. The other thing that you'll do as a part of your homework is also forward anything that comes to this IP address on port 8080 to this server. That will become a little bit confusing because we're not going to forward 8080 to 8080, but rather we're going to forward 8080 to just 80 because that server only listens on port 80. So where you will do that is all within destination NAT. Somewhat similar, but there's kind of another step here. So destination rule set, everything can kind of live under this rule set. I want this to match anything from the WAN zone or the untrusted zone, for example, right? This is where we want to do the destination NAT. Only if the traffic comes from the internet. What do we want to actually do? So you'll add in the rules. You give it some great name first. So within each rule, again, this is where is it coming from? Do I only want to do destination NAT if one specific IP is making that connection, or maybe if the entire internet is making that connection? What port do I want to essentially listen on? So we're going to do 80 if I want to forward any request coming to 80 onto somewhere else, any request onto 8080 to somewhere else, any request to 443 onto somewhere else, something like that. That would be your destination port there, right? This is the WAN interface port, essentially. So if you receive anything from there, what do you want to do? Your options are either don't do destination NAT or do destination NAT. And do destination NAT is something that you should definitely do here. That's the whole point. Now, your only option is with pool, so we're going to add a new pool because there's nothing there by default. And what a pool will be is essentially your server or servers. So if you had a number of web servers that were serving the same content, you could set up a pool with all of those web servers. In this case, we don't. We have two separate web servers with two different types of content. I believe so. I don't know how smart it is to do that. You'll probably have a different device there to do that type of thing, but the feature's kind of there. Right. So if I had a pool for server 1, for example, you need to give it an address and port. So where does server 1 live? An IP for server 1. Where does that website live on server 1? An a port for server 1 would go there. That's how you would define server 1's pool. You do the same thing for server 2 to throw that in there. You'd have a new rule for server 2 because server 2 you're going to be listening externally for port 8080 and not just 80. And that's NAT. That's source NAT and destination NAT within Juniper's. Really kind of all there is to it. You will forget, you will get tripped up, I'm sure. Questions at this point? Okay, I'm gonna go fully through this. So there's like wall of text on here. It's not that bad. Kind of went through this. Default creds are up there. I did set a default password, username and password on the Juniper box there. Palo Alto is just its regular default. Side note, before I go on, when you turn these systems on, it will take a while. And I think we experienced that a little bit last time as well, right? The Juniper looks like it takes forever, and it does. The Palo doesn't look like it takes forever. Sometimes if you turn it on, you're watching it, and you go to log in right away with admin, and it says, nope, those are bad creds. It's because it's not fully turned on yet. It's really dumb that it doesn't show you, or that it tells you can log in before you can actually log in. Just like wait 10 more minutes and try and log in again. And if it still doesn't work, wait 10 more minutes and try and log in again. And if it still doesn't work, then something's wrong, maybe. Right, so just patience on turning things on there. So again, there's your networks kind of diagram. Dog network, goat network. The dog is a Palo, the goat is a Juniper. We just looked at goat's Juniper. So you're going to be configuring each of these. Things that are configured on each of these firewalls right now is the management interface, essentially. So on the Palo, we talked about that management interface is different than the interface that will actually handle traffic on the LAN, for example. So the LAN interface is not configured, but the management interface is configured at 64.43.250.23. So that's how you will access that. The client should be configured already as well. If not, just change that. So you have to configure each of those three interfaces on Dog's firewall with the IPs listed here. You're not configuring it with a .0 IP. Pick the best IP for a router within that range. The WAN interface is very specific. It must be that IP. Same thing down here with GOAT. IPs are listed there. You're not doing a .0, but pick the best within that range for a router. And the WAN IP needs to be a very specific .101 there. On the GOAT firewall, the LAN is already configured for you. That is because that is the management interface, essentially. Let me fix that. Server information is listed there. The server's already configured. There's nothing you should need to do there. We're just really dealing with firewalls here. Oh yes, I should show you this as well. So with the GOAT firewall, you must also configure a route. I intended for this to happen before it got pushed out, but Cody forgot, so we're going to do it now, or I'll show you now. So with the route, under routing,
I'm having trouble getting to the interface.
is Juniper turned on? Like, did you open up the Juniper firewall and look at it and see that it's ready for a login? Because it takes forever. It's slow. So under the static route here, you will need to add a static route for things to work. The IP address for the route, all of this is listed in the doc somewhere. Let me move it over. Okay, so you must configure a route for this. So 6443.00/16 will go here. 6443, whoa. 6443.00. And then we'll do a /16 here to say anything that is destined for there, go to, and then you'll add a next hop, which is this. So 24.220.181.102. 24.220, stop it. 24.220.181.102 is where that will be sent. So that has to be in place. Okay. And that will show up there. That has to be in place for you to be able to access any of Dog's servers from Goat. If that's not in place, you will have problems, guaranteed. Only has to be done on the Goat side. If you didn't get that part, watch the video again. Also, what you need to do is right here, okay? So don't forget that. Once you get all the interfaces configured, you'll be setting up NAT and firewall rules to meet these specifications. So basically all you're doing is allowing access to each server, each of those 4 servers, from the internet. Now you might have to do some other rules like source NAT rules and other firewall rules to allow traffic outbound so people can visit. So on the Dog side, Dog server 1 and Dog server 2 both need to be accessed from the outside, and you will show me that they can be accessed by giving me a screenshot getting to server 1 from the Goat admin machine, so from the other side, right? Same thing down here on the Goat side. You're going to set up Goat servers to be able to be accessed from the outside. You'll show me that it works by opening up the Dog admin machine and getting to the Goat firewalls. Now, the Goat side is a little bit different again because we're using NAT, so you can't just access those 2 servers by IP. There's only one IP, one public IP that we can use, so we have to use different ports. Server 1 will be accessed over port 80. Server 2 will be accessed from the outside over port 8080. It's the only really major difference there. Again, firewall rules and stuff you'll need to configure. You might need to do some other NAT things to allow that traffic to go outbound and inbound. Deliverable, what I need from you, basically those 6 screenshots. So accessing each of those 4 web servers in screenshots, and then your firewall rules. So show me all of your rules for both machines, because if you do an any on everything, it will be wrong, and you will receive less points for that, right? Don't be overly permissive. Restrict it as much as you can. Remember, anytime you're dealing with the internet, though, it's not one IP or one small subnet. That it does need to be a very broad anything. But show me those rules as well. All right, any questions? Yes. Yeah, it's fine. It's fine. Yep, that might be. Nope. Good question. Yeah, actually, that's another good point. So, as you are creating your firewall rules for this, what I need a screenshot of, for example, is this Dog admin machine accessing this server. Don't create a firewall rule on here to allow this IP and only this IP to access that server. Create a firewall rule on here to allow anything on this subnet, anything on that LAN subnet. So if that IP did change, which it is different in practice than what it actually is on here. But with these two machines, it doesn't really matter. This machine will be accurate. Everything else needs to be accurate, but these two admin machines doesn't actually matter. It's a good question and a good point to bring up. Anything else? Okay. What is there, like 20 minutes left of this class? Yay. Rest of the time is yours to start on it if you want to. Thursday will be a work day. You should definitely take advantage of that, especially if you're not done and expect to have questions. So I'll see everyone then. Have fun. This will be due Monday at this point at 5, like normal.